Hello pandas and other trash enthusiasts. Today on Project Junk we are going to be looking at 7 different 4.5-inch cutoff wheels to see how they compare when cutting a soft metal like copper. There are a lot of different products in this space and it'd be nearly impossible to do a comparison of all of them in one video, so instead I've chosen all the different styles I could come up with and we'll compare those. Now there doesn't seem to be any copper specific cutoff wheels, but there are some made for aluminum, and they're different because soft metals like copper and aluminum will form long stringy crystalline shapes and they tend to absorb and transfer heat really well. So in practice that means they gum up the different abrasive cutting wheels and clog them, reduce their cutting ability, and cause a lot of heat from additional friction, which makes them wear out a lot quicker. Now, unlike the channel I'm clearly drawing inspiration from, I do not have a metal arm set up on hinges with an angle grinder and a bunch of weights on top to simulate the exact same conditions. But despite that, I will be trying to remove the human element as much as possible and make it as fair as possible. So I've set up 4 different copper wound motors of similar size for each of these wheels to go up against. I'll be using the same 110 volt plug-in angle grinder, so none of these discs are suffering from working with a weak battery, and all the motors will be mounted in a vise so that none of them are walking away. That's as fair as I think I can get it. Despite that, this is not scientific, so the results are going to be subjective. That said, we'll be ranking them based on how long it takes them each to get through 4 motors, how much cutting material is left after they've done so, and the initial cost of each disc. When finished, I hope it'll be clear which one of these products is the best use of your or my time and money when it comes to cutting through copper windings with an angle grinder.
Now, first up, to create a bit of a baseline, we'll use the old reliable, the aluminum oxide cutoff wheel. This is the cheap one that you can find everywhere, and I've heard if you cut into a piece of wax, you can help prevent it from getting all gummed up by copper or aluminum. Speaking of aluminum, that one was, but I don't think it's going to affect our results that much, so we're just going to soldier on. And getting through 4 motors took us almost 5 minutes. Comparing how much was worn off, it's maybe 1/8 of an inch. Not a bad starting point. Now the next one up is a little more expensive because this is an aluminum specific cutoff wheel with a zirconium grit. How different will our results be? I'm not sure. Honestly, it doesn't feel that much easier. It did shave a minute off our total time, but I don't think that's because it was easier. I think I was just doing a better job. Now the total amount worn away actually looks like it's a little bit more than the cheapo solution, which is too bad. Now the next one is also an abrasive cutoff wheel specifically for aluminum, but this one is a silicon carbide grit. That also makes it more expensive again. And honestly, it's working great, but it took about the same amount of time and wore down the same amount as the previous one. Now we're going to try something a little different. This one's a bit of a dark horse, but I wanted to try it even though it's rated for wood because, well, I wanted to see. And I did see. Yeah, that was pretty sketchy. That made a mess. That was actually kind of dangerous. So that one's disqualified out. Now the next one is also not really for aluminum or metal at all. This is a diamond-tipped masonry cutoff wheel. These are a little more expensive, and it was doing okay, but it was going really slow, and then, yeah, it got caught up. I don't really want to mess around with stuff like that. So now we're into the good stuff. We're at about the same price point, but this is designed to cut metal. Steel specifically, but it's not getting caught up. It's actually doing a great job. And at 435, it's right on par with the other ones. Looking at how much was worn away, it seems to be missing some paint, but it doesn't seem to be missing any of the diamond grit on the edge, so that's not bad. Now at the top of our cost range is another segmented diamond edge metal cutoff wheel. This is the Lennox, which most reviews seem to put on par with the Diablo. The Diablo was sold out, so this is what we've got. And it's doing well. It's doing fine, but is it doing that much better than the previous one, which costs half as much? Well, it did cut some time off, 20 seconds. As far as the wear is concerned, it's pretty much the same. It's lost its paint, but the diamonds still seem to be on there. And this, just for fun, but not really in the comparison, people have told me you can use a wood blade to cut. No, no, we're not doing that. I've used this for aluminum before, but I shouldn't really be surprised it doesn't like the windings.
Well, once again, these are not scientific tests, and therefore these are my opinions. However, I think that we still have enough evidence to draw some conclusions. First off, any discs that presented a very real danger were disqualified, and obviously that means they are not the best cutoff wheels for cutting through copper windings. More importantly, though, when it comes to power tools, it would be foolish to get creative, and we should use equipment for its intended application. Especially when it comes to stringy, gummy things like copper or aluminum windings wrapped up with little bits of string. Blades like masonry or wood blades have gaps that are way too big and are likely to get tangled up and put the user at risk. These wood and masonry blades may still be good for cutting sheet or bar stock, but for windings, that's a hard no. Moving on, I was surprised at the performance of some of the other discs, specifically the abrasives. The aluminum oxide was slow, but probably due to human error more than anything, because that's the first one I used. I'm not sure how much dipping it in wax helped, but it didn't underperform compared to the zirconium or the silicon carbide. Those latter two may perform better when used on a thicker workpiece, but in this application, there seems to be no meaningful difference between the three abrasive types when it comes to speed or durability. The same seems to be true in comparing the Lennox and the Easy Arc diamond tip blades. They both seem to move at the same speed and show similar signs of wear. With that in mind, it seems difficult to justify paying nearly twice as much for the Lennox. So based on these tests, I'm drawing two winners. The Easy Arc Metal Master is a high performer that will save you time by not having to swap out multiple discs in one job if you can justify paying $12 a disc. And if not, the cheapest aluminum oxide abrasive wheel will do great, especially if you cut into a piece of wax to help prevent it from getting gummed up. Neither of those seem to waste less of your material than the other in the form of copper shavings, but the Easy Arc does make less of a mess as it doesn't need to abrade away to do its job. I hope this comparison helps you in deciding which cutoff wheel to use for cutting copper windings. I know I'm glad to see it doesn't really matter if you cheap out, as long as you're using a metal cutting wheel for cutting metal. Like and subscribe for more scrap metal content, and I'll see you in the next one. Leave it better than you found it. Keep doing the thing.